మేడం గ్రీష్మ మేడం గారు. గ్రీష్మ మేడం గారు. మేడం గారు. మేడం గారు గ్రీష్మ మేడం గారు, ఈజ్ మై వాయిస్ ఆడిబుల్?
Sir, I can hear you.
Madam, please start the meeting, madam.
Sir,
Madam, start the meeting, madam.
so should we start, sir?
Yes.
Madam.
So, good morning once again to all the participants. Let us start the session with our today's chief guest, Dr.B.T.Krishna garu, with his keynote address.
స్టార్ట్ చేయమంటారా?
Sir, B.T. Krishna garu.
మేడం చెప్పండి.
Sir, you can start the session, sir.
Thank you. I will start. Is my voice audible, madam?
Yes, sir. You're audible, sir.
Okay. So good morning, everyone. So
We can hear you, sir.
okay, madam. Start చేస్తున్నానండి. I am starting the session.
Yes, sir. Start చేసేయండి, sir.
Okay.
Go ahead. Go ahead, sir. Thank you.
So good morning,
Sir, can you hear
everyone.
me, sir?
So Grishma garu, I have started the session అండి. No problem. So today I am going to give a presentation on machine learning and its applications. I have taken applications in particular to electronics and communication engineering. So I am Dr. B.T.Krishna. So working as a professor in JNTU Kakinada in EC department. So this is the overview of the presentation. So basics of the machine learning and what are the various types of machine learning will be discussed. Then what are the various applications in electronics and communication engineering, such as signal processing, wireless communications, and antenna engineering, and VLSI is also going to be discussed. Then what are the softwares that have to be used to work on this MATLAB will be discussed. The work on this machine learning will be discussed. Those softwares are nothing but MATLAB and Python. And we are going to give some information about some toolboxes in MATLAB and some of the libraries in Python. And this is the overall view of the presentation. First, let us see the definition of the machine learning, and let us understand what is meant by machine learning. So machine learning is a branch of artificial intelligence, concerns the construction and study of systems that can learn from data. This is the definition that is available in the Wikipedia. We have taken this definition from the Wikipedia. So it is one branch of the artificial intelligence, and it deals with the learning from the data. That means you will have a system. That system is going to learn from the data. This is what is meant by machine learning. And another way of saying it, machine learning is a subfield of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. This is another way of saying the defining the machine learning. It is a subfield of artificial intelligence, and you will have a provision to automatically learn and improve from the experience. That means from the previous data, you are going to previous output data, you are going to learn whether the given condition is satisfied or not. So based on that, you will learn you will learn again and again and again, and so on and so forth until the given condition is going to reach. This is what is meant by machine learning. So in the beginning of the machine learning, we are going to give some input to the selected algorithm. So to test this algorithm, whether this is working or not, we are going to give some data to it. Then the prediction and results are going to be checked. So you will have a machine learning algorithm. To that, new input data is going to be given, and based on the prediction, the output is going to be checked. So if the prediction is as per as your expectations, that means if the prediction is as per as your requirement, then the criteria is going to be stopped. Otherwise, the algorithm is going to be implemented again and again, multiple number of times, and until and unless the desired output is going to be obtained. So this is what is meant by machine learning. That means in your signal processing, in electronics and communication engineering, you will have one algorithm named as system identification algorithm. Here, in the system identification algorithm, you will have an unknown plant, and you are going to give some data to the known plant. So the error is going to be checked. That means the difference between the expected output and the practical output is nothing but the error, and this error has to become equal to 0 in the ideal case. So like that, in the machine learning also, this the output is going to be checked for each and every iteration, and we will check whether our expectations has been reached or not. If they are not reached, then again the algorithm is going to be run, and this is continued until the desired output is found. So as a summary of this, one way of saying the machine, in the case of machine learning, it is a branch of artificial intelligence, and it provides an ability to the systems to learn themselves. Um, and this third point is, we will give some input data, and we will check whether the expected output is obtained or not. If it is not obtained, then it is the algorithm is going to be run again and again until the desired output is found. So this is the slide which gives you the relationship between artificial intelligence, machine learning, and deep learning. These are the three terms nowadays most frequently used terms. So artificial intelligence is the is a field which covers everything related to making machines smarter. That means smarter means it is nothing but let us take an example of robot or self-driving car. So they are nothing but smart machines. There will be no human intervention is present in the case of artificial intelligence. So let us take an example of Deep Blue, which is nothing but a chess playing computer developed by the IBM company. So this has defeated the world famous chess champion in the 1996 or 97. So that means artificial intelligence deals with everything related to machines which are smarter. So machine learning, whereas machine learning is a subset of the artificial intelligence, and here we will based on the algorithm, uh, this training is going to take place, and the output is going to obtain in the machine learning process. And as far as the deep learning is concerned, it is a type of machine learning, but the input to this deep learning is nothing but large data sets. Input to this deep learning is nothing but large data sets. That means, as a summary, artificial intelligence is going to mimic the human intelligence. That means a duplicate of the human being. But whereas in case of machine learning, we will extract the knowledge from the data. And in case of deep learning, it is same as the machine learning, but it works on the large data sets. So here is the clear difference between artificial intelligence and machine learning. So artificial intelligence is a technology which enables a machine to simulate human behavior. That means here, for example, a robot, also or a self-driving car. So this is about artificial intelligence. But machine learning, as I told you, it is a subset of artificial intelligence which allows a machine to automatically learn from the past data without programming explicitly. So this is going to learn from the past data. So the goal of AI is to make a smart computer system like humans to solve complex problems. But in the case of machine learning, the goal is to allow machines to learn from data so that they can give accurate output. In the one case, we are duplicating a human being, and in the case of artificial intelligence, we are going to duplicate a human being. But in case of a machine learning, we will allow machines to learn from data, and the output should be more accurate. In case of artificial intelligence, we will make intelligent systems to perform many tasks like a human being. I told you that robot and self-driving cars are the examples of the artificial intelligence. But in case of machine learning, we will teach machines with data to perform a particular task and give an accurate result. That means machine learning is having a limited scope, whereas artificial intelligence is having a large scope of applications. So in the case of artificial intelligence, we are making an attempt to produce a machine which will think like a human being. But in case of machine learning, the machine is going to be teach or trained with some data to perform a particular task. This is the clear distinction between artificial intelligence and machine learning. So in case of artificial intelligence, you will have two subsets. One is machine learning and deep learning. Whereas in case of machine learning, we are having only one subset, which is nothing but deep learning. So, and at the same time, the main applications of artificial intelligence are Siri, customer support using a cat boards, expert system, online game playing, intelligent humanoid robot, etc. These are some of the applications of the artificial intelligence. Whereas some of the applications of machine learning are online recommended system, Google search, Facebook auto friend tagging suggestions, etc. are some of the applications where machine learning is going to be used. You are having so many applications. These are some few of them. So artificial intelligence can be subdivided into three parts. One is the weak artificial intelligence, general artificial intelligence, and strong artificial intelligence. So at present, in the case of weak artificial intelligence and general artificial intelligence, we can make an attempt to mimic a human being. So, but we are in the present generation, we are with weak artificial intelligence and general artificial intelligence. In the future, you will have a strong artificial intelligence in which the machine which has been produced by the human being may be more intelligent than a human being. This is what is meant by strong artificial intelligence. But in the present situation, we are at weak artificial intelligence and general artificial intelligence. But in case of machine learning, you will have three subcategories in it. One is the supervised learning, another one is unsupervised learning, and the third one is the reinforcement learning. We will study in detail about supervised learning, unsupervised learning, and reinforcement learning. So the artificial intelligence, it includes learning, reasoning, and self-correction. So these are the three vital points that are related to the artificial intelligence. But whereas machine learning, it includes learning and self-correction when introduced with new data. So that means it will take new data, it will learn from it, and it will check whether the desired result has been achieved or not. If it is not achieved, then it will do correction by itself. So artificial intelligence completely deals with structured data, semi-structured data, and unstructured data. Machine learning deals with the structured and semi-structured data. That means structured data means it is clearly defined, a data which is clearly defined and which is having going to contain some quantitative information in it, quantitative. But whereas in the unstructured data is a qualitative one, unstructured data is a qualitative one, and we have to work to do work to process and understand what is the unstructured data. So in case of artificial intelligence, you can give any type of input, whether the data contains structured, semi-structured, or unstructured. That means semi-structured one is the data is the one which falls between structured data as well as the unstructured data. So, but whereas machine learning, it deals only with semi-structured data and structured data. So it will take, it should have information about quantitative only, quantitative one only. So it should be clearly defined. The input data should be clearly defined. This is the differences between artificial intelligence and machine learning. Now let us see what are the different types of the machine learning. We are having three types of machine learning. One is the supervised learning, and the other one is the unsupervised learning, and third one is the reinforcement learning. We are going to have so many number of algorithms based on these first two types of learnings, whether it is supervised learning or unsupervised learning. So first let us see this classification. This is the classification in which the machine learning has been divided. So it can be, there are three types. One is the unsupervised machine learning, unsupervised learning, and the third one is the reinforcement learning. So supervised machine learning means machine learns from the training data. So machine is going to learn by, and it will do corrections by itself from the training data. In case of unsupervised learning, the basically we do not need any training data. Unsupervised learning does not need any training data. Whereas reinforcement learning, the machine is going to learn by itself. So this is the reinforcement learning. So machine learns on its own. In case of reinforcement learning, machine learns on its own. So this is clear distinction. This picture has been taken from Dataflyer website. So this is a clear difference between supervised, unsupervised, and reinforcement learnings. In one case, we need to provide some training data. In another case, there is no need to provide any data. And in the third case, machine learn on its own, which is nothing but reinforcement learning. So first, let us see about supervised learning. So here you see, this is the data, labeled data, and some arbitrary input has been given and the model is going to be trained, and testing data is also given, which contains some triangular symbol and a rectangular symbol, and this takes these data, so it was trained, and it is going to separate, it is going to produce variables as a square signal as well as a triangle output. That means this shows it will take some data which is going to contain a mixture of so many types of labels, and it is going to separate, see, the labels at the output end. So that means in case of a supervised learning, the training data provided to the machines work as the supervisor. That means as a teacher it works, and it teaches the machines to predict the output correctly. It applies the same concept as student learns in the supervision of the teacher. That means this operation principle resembles the classroom teaching. So in here, in the case of supervised learning, it is a process of providing input data as well as correct output data to the machine learning model, and you will have a transformation or a mapping function from the set of input data to set of output data to which is going to be produced. So the aim of a supervised learning algorithm is to find a mapping function to map the input variable x with the output variable y. So such type of mapping operation is going to be done in the supervised learning. So now in this supervised learning, there are two categories. One is the regression, other one is the classification. So regression is the task of predicting a numerical label, whereas the classification, it is the task of predicting a class label. That means supervised learning can be classified into two ways. One is the regression learning, and other one is the classification type, regression type and classification type. So in one case, a numerical label is going to be predicted, and a classification is the task of predicting a class label. And these are some of the supervised learning techniques or algorithms you can call. So here under regression category, you will have simple linear regression, multiple linear regression, polynomial regression, decision tree regression, random forest regression, support vector regression. These are some of the algorithms which falls under the category of the regression. Whereas in the case of classification, you will have logistic regression, k nearest neighbors based classification, naive based classifier, support vector classification, random forest classification, decision tree classification. That means studying supervised learning is nothing but knowing about all these type of algorithms one by one. So you have to study the in-depth theory of these algorithms which has been mentioned in this slide. You have to study about KNN algorithm, naive Bayes algorithm, support vector machine classification, random forest classification, directory classification. We have to study about the theory of these algorithms. But here the main intention of this slide is to give an overview of the what are the different types of the supervised learning algorithms. So now let us see what is unsupervised learning. So here an algorithm, here you see an unsupervised algorithm is present here, and there is a processing step is going to be taken, and data is given in a random manner. Input raw data is going to be given, and output is produced half an hour. And output is going to be produced like this. So unsupervised learning describes a class of problems that involves using a model to describe or extract relationships in data. Compared to supervised learning, unsupervised learning operates only on only the input data without outputs or target variables. Unsupervised learning does not have a teacher. This is the main point we have to remember. Now, this unsupervised learning is also can be classified in two ways. These are, one is the clustering type and other one is the dimensionality reduction. In dimensionality reduction, you will have several algorithms, and in clustering also you will have several algorithms. So clustering is nothing but finding the groups in the data. You will have a good data, and let us take different colors. So separating a color data into one group is nothing but clustering. Similarly, whereas dimensionality reduction, that means here the dimension is going to be reduced in the case of dimensionality reduction. Let us see in detail about different types of unsupervised learning algorithms. So here you will have clustering and dimensionality reduction as the two constituent parts of the unsupervised learning. In the clustering part, you have to study about k-means clustering, mean shift clustering, EM clustering, DB spatial clustering, hierarchical clustering. And in the dimensional reduction, you are having a linear discriminant analysis, NDA technique, principal component analysis, PCA technique, and generalized discriminant analysis. These are some of the algorithms that are going to be used in the unsupervised learning. Now let us see what is the difference between supervised learning and unsupervised learning, and let us understand in a more clearer manner about these type of learnings. So the supervised learning algorithms, and as I told, they are going to be trained using a labeled data. Unsupervised algorithms, they are trained using a unlabeled data. So supervised learning model takes direct feedback to check if it is predicting correct output or not. But in case of unsupervised learning, you will not have any feedback. I think all of you know what is the feedback. So supervised learning model predicts the output. Unsupervised model finds the hidden patterns in the data. So this is the main difference. In case of supervised learning, there will be a prediction, and if the prediction is up to your level, up to your specifications, then the predicted output is the actual output. If it does not meet the requirement, then again there will be using feedback that is going to be corrected. In supervised learning, input data is provided to the model along with the output. In unsupervised learning, only input data is provided to the model. This is the important point. In the case of supervised learning, input data is given as well as output data is going to be given to the model, but accordingly it is going to be trained, and we will check whether it has succeeded or not. But in case of unsupervised learning, only input data is provided to the model. So the goal of the supervised learning is to train the model so that it can predict the output when it is given a new data. The goal of unsupervised learning is to find the hidden patterns and usual insights from the unknown data set. So this is about the working principle of the supervised learning as well as the unsupervised learning. Supervised learning needs supervision, whereas in the case of unsupervised learning, it does not have any supervisor. So this is just like classroom teaching. Supervised learning is just like a classroom teaching. So supervised learning can be classified as classification and regression problems, whereas this can be classified as clustering and other problems, association problems. So supervised learning can be used for those cases where we know the input as well as the corresponding output. But whereas unsupervised learning can be used for those cases where we have only input data and no corresponding output data. So the result produced by the supervised learning is more accurate, whereas the result produced by the unsupervised learning is less accurate compared to the supervised learning. It includes supervised learning includes various algorithms such as linear regression, logistic regression, support vector machine, multi-class classification, decision tree, Bayesian logic, etc. Whereas in the case of unsupervised learning, there are several algorithms such as clustering, k nearest neighbor algorithm, and a priori algorithm. These are some of the algorithms that are present in the case of unsupervised learning. So this table gives you the difference between supervised learning as well as the unsupervised learning. Now let us go to the other type of machine learning algorithm, which is nothing but the reinforcement learning. In the case of reinforcement learning, this describes a class of problems where an agent operates in an environment and must learn to operate using feedback. So this is somewhat similar to the supervised learning. Here there is a presence of the feedback, and reinforcement learning is learning what to do, how to map situations to actions so as to maximize a numerical reward signal. So the learner is not told which actions to take, but instead must discover which actions yield the most reward by trying them. This is about reinforcement learning. So here there will be an agent. So he will and at the same time there will be a feedback. So this describes a class of problems where an agent operates in an environment and must learn to operate using feedback. So this is about reinforcement learning and different types of machine learning techniques that are possible. Now let us see what is the block diagram. That means whenever you are studying about any concept, basic workflow should be there. Let us suppose you will study about analog signal processing block diagram, digital signal processing block diagram. So let us see what is the block diagram of the machine learning. So this is the block diagram. So here this is the workflow how the output will be produced from by taking input. So the first step that we have to follow is nothing but collect the data. So collect the data, how data will be collected. Let us take data. Let us go to some signal processing or some other point of view. We will have some sensors. Sensors will produce some data. Let us take a cell phone. Cell phone will produce some data. You are having some table of information, which is nothing but data. There are various types of ways to collect the data. So first step we have to do is collect the data. Next up is prepare the data, preparing the data. That means whenever you are giving as an input, that means whenever this data is given as an input, it should be clearly understand by the algorithm to which we are giving. So in that way, we have to prepare the data. Let us take, I have to plot a graph between X variable and Y variable. So the data has to be prepared, organized in two columns. First one should contain X variable data, and other one should contain Y variable data. Like that, I have to prepare the data which is to be understood by the algorithm. Next, exploring the data. Exploring the data means, let us suppose I have plotted it. It is clearly coming or not. Okay, it is, if it is clearly coming, this can be tested. Exploring the data can be done by drawing a XY plot, or a two-dimensional plot, or a three-dimensional plot. You can plot, and like that. Then the data should be given as an input to train the algorithm. Then the algorithm has to be tested repeatedly by giving different samples of data. That means in the first attempt, I will give one table, and the second attempt, I will give another table of data. Like that, different types of data has to be given to algorithm. Then I have to check whether it has produced the correct output or not. So that is nothing but if I will have some specifications. Specifications means the error should be equal to 0. That is the specification. Or the gain of the amplifier should be so and so. That is my specification. Or bandwidth should be so and so value. That is my specification. I will check whether this has been reached or not. That is what is meant by evaluating the algorithm. Then improving, if I will take care of any optimization steps to improve the performance of the algorithm in a more to get more accurate result as I have obtained. So in this training, you will have two types of learning. Again, one is supervisor based learning, or it can be an unsupervised based learning. So this is the workflow of the machine learning workflow. So let us go in details about this. First one is the collect the data. So data gathering is the first step of the machine learning life cycle. In practice, it is collected through lengthy procedures. For example, derived from measurement campaigns or face-to-face interviews, or it can be data produced by the cell phone, or it can be anything. It can be an output of a sensor. You can measure it using a voltmeter. It can be a reading of the ammeter. It can be the display from the CRO tube. That means why I am telling all this is since because in this assembly, most of you are from EC background. So these are some of the ways in which we are going to gather the data. Once, let us suppose I have gathered the data. Let us take a meeting. Let us take this meeting. This is the microphone I have used. This may contain some noise such as fan-based noise or some other thing. Then that has to be filtered out. That is what is meant by preparing the data. That means after collecting data, we need to prepare it for further processing. That means I have to remove the noise. Let us take, we have gone to hospital. 12 leads has been connected to get ECG signal. Some noise is present in the ECG signal. That noise has to be first processed. It has to be removed by making use of some filters. That is what is meant by preparing the data. Then once the data has been prepared, I have to check whether it is correct or not. Okay, that is nothing but exploring the data. This can be done by either plotting it or some other ways. Okay, and the data has to be converted into useful format. That is what is exploring data. Then next step is nothing but the training the algorithm. So in case of training, that means the data is going to be given to train the algorithm. Then the testing the algorithm. Once our machine learning model has been trained on a given data set, then we will test the model. In this step, we check for the accuracy of the model. That means we will have some criteria or a specification to be met. Then we will check whether that specification has been matched or not. If it is matched, okay. Then if it is not matched, then we will go back to the first step. That means training the data. Then evaluating the algorithm. So we can access the approximation ability of the model by applying it to real data. The model preventively trained and tested is then valued in this phase. That means here we will check everything, whether it is working perfectly or not for any type of data. Evaluating means you will give so many number of data inputs, and we will check for number of trials it is producing the correct output or not. Improving the algorithm performance. Finally, we can focus on the finishing steps. We have verified that the model works. We have evaluated the performance, and now we are ready to analyze the whole process to identify any possible room for improvement. This is that means here you will make use of some optimization techniques. That means those are not genetic algorithm, not like that. You will, in general, you will have some procedure you will follow to improve the algorithm performance. So this is the cycle, machine learning cycle. So how this machine learning is going to work. So now that we have studied some basics of the machine learning, and we have learned how what are the different types of machine learning that are present, what is the machine learning cycle or workflow. Now this machine learning is nowadays finding applications in all branches of engineering. It can be civil engineering, computer science, or anything, and it has become a specialization. So many colleges have started offering B.Tech in artificial intelligence and machine learning. So many M.Tech specializations are also has opened, but we cannot study all the applications. But since we are electronics and communication engineering people, I have taken some examples where this machine learning finds applications. We will discuss about the pros and cons of these applications also. First, let us see the most widely used area, signal processing. In the case of signal processing, first application is speaker identification. Let us take in this group, in this assembly or meeting, 50 people are present. So since your mics are has been muted, you are not speaking. So let us suppose your mics are on, then 50 people are speaking simultaneously. Then identification of my voice, it is speaker identification. So then what it is called as the cocktail problem. Then we will make use of the principal component analysis or independent component analysis to identify what is B.T. Krishna is speaking. Let us suppose people are 100 people are present. Identification of the, that means 100 database will be put in a room in a particular box, and if identification of yourself or the object of your interest. Let us take all vegetables, and the different types of objects has been placed in one room. How to identify a particular object? Let us take tomato or some brinjal, some other table identification, computer identification. You are having a large data set. In that identification of your face, so yeah, that means you are having a large data set containing photos. In that identifying correctly your face is a face detection problem. Identifying object of your interest, whether it is cell phone or a charger or a table or anything, that is your object detection problem. And the image segmentation is also another problem which is in which machine learning finds applications. That means they will find application in classification or at any stage grouping together. That means nothing but clustering phenomena, which falls under the unsupervised learning, and so on and so forth. Similarly, ECG signal, as far as the biomedical engineering is concerned, you will have so many number of action potentials. They are nothing but biopotentials. They are called as biopotentials. So electrocardiogram signal, which is related to heart, electroencephalogram signal, which is related to brain, electrooculogram signal, which is related to eye movement, electromyogram signal, which is related to nerve. All these are some examples of the biomedical signals in which you are going to work if you are interested in biomedical engineering field. Then ECG signal is going to contain PQRST. So identification of the QRS complex, identification of the ST segment, identification of the T wave, U wave. All this is an example of the machine learning algorithm. So here he has taken heartbeat classifier, ECG heartbeat classifier. In that classifying classifiers, different classifiers has to be studied. So they are nothing but support vector machine, Bayesian classification, neural networks, linear discriminant analysis, k-nearest neighbor, decision trees has been taken. And you can compare the performance of all these classification algorithms, and you will take one figure of merit, which can be an accuracy, or which can be some other value, and you will compare support vector machine, Bayesian classification, neural networks with each other, and you will prove that the particular one is good compared to other one based on the accuracy or other thing. That is one way of taking a B.Tech project work or M.Tech project work, comparing all the machine learning algorithms. Similarly, EEG signal classification. In case of EEG signal classification, you will have alpha, beta, gamma waves, and you will take data from www.physionet.org, which is maintained by Massachusetts Institute of Technology, USA. So the database is the accurate database. From that database, you will take ECG data, EEG data, and you will apply these machine learning algorithms such as classification algorithm or regression algorithm, and you can go for the classification of the EEG signal also. So these techniques may be used for the prediction of the disease that is present in the human body based on the input signal that has been taken. So recently these are the routine tasks that everybody is to done. Many people have used artificial neural network in the speaker identification, face identification, image segmentation. Now they are using some of the machine learning algorithms which I have presented in the previous slides. Similarly, nowadays, new topic in this area, biomedical engineering or signal processing, is brain machine interface, BMI, or BCI, brain computer interface. That you can work since you may be in final year or M.Tech first semester people. So they can take this as an exercise. This is the block diagram. So in the first step, measurement of the brain activity signal, brain activity signal is going to be taken. Then it is going to be processed, feature extraction, feature extracted in feature. Then classification is going to be done. Again, it will check for the desired result, and feedback is going to be given if the condition has been satisfied or not. Then again, the same thing is going to be continued. That means brain machine interface or brain computer interface using these machine learning algorithms is a new topic. I got one textbook which is written in 2020. This diagram is taken from textbook which is written in 2020. So let us see how this BMI is going to work by going through this slide. So first one is the data acquisition unit. As I told you, for any machine learning algorithm, first we have to provide some data. So brain activity can be the brain activity can be monitored by connecting various types of sensors. So then the noise has to be reduced. That means that is going to be done by making use of filters, and these are the inputs to the BMI system. Then a pre-processing unit. That means this unit reduces noise and any artifacts present in the brain signals in order to enhance the relevant information needed in the input signals. Then feature extraction. The feature extractor transforms the pre-processed signals into feature values, thus corresponds to the underlying neurological phenomena. These features are employed by BMI for controlling the output device. And the classification unit, this part is responsible for identifying the intention of the user from the extracted features. So that means here classification is going to be done. And output device can be a computer or a wheelchair or robotic arm, etc. That means in the classification unit, what it will do is I want to move the chair, I want to handle something, and at the same time I want to use my arm. These are the outputs of the classification unit. Accordingly, the output device is going to respond. And feedback, ideally BMI should be a closed loop system such that the system shows the output to the user after processing the brain signals. This is the new one I have found. Machine learning algorithms are going to be used for the classification purpose, and the patient who is not in a position to move, can order he want to do something, he want to read a newspaper, he want to do something. So this is the one of the application in the biomedical engineering, or it can fall under signal processing also. So now let us go to the communication engineering. In communication engineering, these are the methods: k nearest neighbor method, classification methods, support vector mission, logistic regression, multi-layer perceptron means it is artificial neural networks. Deep learning is nothing but ML with big data, that means large data set. Like that, these are some of the methods, and this is the basic function: classification or regression. That means this says whether it is supervised learning or unsupervised learning. These are the applications in the wireless communications. So you see here the fall detection, energy enhancements, congestion control improvement, monitoring animal behavior, intrusion detection, and obstacle detection. And similarly, memo channel learning, and traffic classification. And these are some of the applications in the wireless communication, which is nothing but supervised learning applications. All these are under supervised learning applications in the wireless communications. Now let us go to the unsupervised learning applications. Here, these are the methodologies they have followed: k-means clustering, DB scan method, and Gaussian mixture models, principal component analysis method, autoencoder. And here, this is the basic, whether it is clustering technique or dimensionality reduction. That means in now unsupervised learning, you are having two classifications: clustering or dimensionality reduction. And these are the applications: collaborative signal processing. That means K-means algorithm can find applications in wireless surveillance systems, wireless hybrid networks. DB scan method, it is a clustering function, and it finds applications in power backup, anomaly detection, localization, wireless agriculture. Similarly, Gaussian mixture model, this finds applications in target tracking, signal strength prediction, and autoencoder, which falls under the category of dimensionality reduction, will find applications in wireless data representation, localization, anomaly detection. So these are some of the applications in the wireless communications. If you are interested in mathematics, you want to do mathematics as well as the machine learning techniques, then these are the three areas in which you can apply machine learning algorithms. One is nothing but channel modeling, and other one is channel prediction, and other one is the channel estimate, channel estimation. So channel modeling is one of the most important research topics for wireless communications, since the propagation channel determines the performance of communication in it. So channel modeling using machine learning algorithms, somebody might have worked on it. You can download a paper and you can make use of another machine learning algorithm, a new machine learning algorithm. You can compare the performance, and that is B.Tech project work or M.Tech project work you can do. Similarly, channel prediction based machine learning algorithms, based on machine learning algorithms, this is also a topic of which is growing. And these three topics has been taken from textbooks which are written in 2019 and 2020 above. So channel estimates are required by wireless nodes to perform essential tasks such as pre-coding, beamforming, and data detection. So beamforming application using machine learning algorithms is also a good topic of interest. So these are some applications in the applications of machine learning in the area of communications. Now let us see how this machine learning algorithm can be applied in antenna engineering. So by antenna, in the case of antenna engineering, in machine learning algorithm, the basic requirement is always getting a data. So first you have to do some simulations using some softwares, HFSS or any other software. The electromagnetic characteristics of antenna has to be found out. Then these characteristics are stored in a database and used as data set for training a certain machine learning algorithm. That means the data set that is going to be obtained from the simulations by making use of some simulation softwares. Then the antenna that gives the closest results is designed by the algorithm after making predictions depends upon the needs of the designer. This is the following. These are the steps first we have to do in order to apply the machine learning to antenna design. So in one of the recent papers, they have designed a rectangular microstrip antenna using support vector machines. And although I have written this procedure, some people may understand or not, but you have to remember that rectangular microstrip antenna or some microstrip antennas can be designed by making use of these machine learning algorithms. So, and at the same time, once the antenna has been designed using these machine learning algorithms, whether it is artificial neural network or any other thing, then you can make use of the evolutionary computation algorithms such as a genetic algorithm, particle sum optimization, anti-colony optimization, and you can improve the performance of the antenna by making use of these evolutionary computation algorithms. So this is one of the application. You can. This is a simple conference paper written in 2020. From this is some information has been extracted to explain. That means to give a new idea to people, to students, particularly B.Tech and M.Tech students, how the whether the machine learning can be applied in antenna engineering or not. And at the same time, in the case of VLSI design, you are having several steps, the various levels of abstraction, and at the same time you are having photolithography technique, oxidation technique, and there are so many number of steps in the manufacturing of the IC. So nowadays machine learning techniques are used to have good photolithography technique. In that means in the physical design process, in the physical design process of the levels of abstraction. So these machine learning techniques are being used. And at the same time, once the amplifier has been designed using CMOS or other thing, then improve its performance can be done by making use of the machine learning algorithms. I have found 2 or 3 papers, but yesterday night only I found, since it does not found time to include it in the presentation. In VLSI design also, particularly EDA, EDA. So in that area, these people are making use of the machine learning algorithms in the field of VLSI also. Now these are some of the applications in particular to electronics and communication engineering. I have given some applications in VLSI, biomedical signal processing, image processing, wireless communications. That means machine learning is finding applications in all branches of engineering. But we should be particular to I have limited this presentation only to electronics and communication engineering. So now the question is whether all the machine learning algorithms are suitable to be used in all applications or not is the question. What are the challenges? So challenges is in applying machine learning algorithms to electronics and communication engineering is the question. So these are some challenges he has written in one paper. He has written the choice of learning algorithm. It is not easy to decide what algorithm to choose, as there are great number of them. This depends directly on what is being predicted and also on the type of the data required. A good practice is to always visualize the data before choosing the algorithm. So this is what we will do in the workflow of the machine learning algorithm. Always we have to check whether this data is understood by the technique or not. And at the same time, you are having several algorithms in supervised classification and unsupervised learning classification. It is not that much of easy to decide. That means here this is the trial and error method, because we does not know which algorithm is going to produce a good result compared to which algorithm. So this is the first difficulty that we will face. That means the choice of algorithm is a big question while working on antennas or on other algorithms. Next one is problem formulation. Next step. That means I am telling you about the limitations of the machine learning in the antenna engineering. Problem formulation. Beginning with wrong assumptions usually lead to worthless results that can cost a lot of time. It is necessary to know what area of the problem is best to spend time working on. So let us suppose you are working with an antenna with so and so gain, with so and so S21 value or S11 value. So if you have started with the wrong assumption, then what you have to do, you have to simulate using HFSS or IE3D or any other software. Then you have to prepare the database. The database has to be given as an input to machine learning algorithm. Then you have to check whether the correct output is obtained or not. Then if it is not done, that means this time consuming process. So while formulating the problem itself, we should be careful and getting enough data. Some data can be hard to find or obtained. In antenna design, multiple simulations are needed in order to obtain a training data. This is another problem. And pre-processing data to ensure that the learning algorithm performs adequately, multiple steps need to be performed on the data, such as data cleaning, normalization, feature selection, which would cost time in case of very large data sets. So this is also, that means in signal processing, this pre-processing of data can be done with a simple one or two instructions. A low pass filter or some noise elimination MATLAB command will be given. Pre-processing of the data. But in other simulations, this may not be possible. It may be a time consuming. And debugging the algorithm, knowing what to do next can also be challenging. When problems such as high bias and high variance occur, it is crucial to know what step to take. This requires following some diagnostic techniques such as plotting the learning curves. That's why I told in the machine learning steps itself, workflow itself, whenever you are working with data, it is better to plot it. Then you can give it as an input to the training data. So these are some of the difficulties, that means practical difficulties in machine learning while applying machine learning to antenna or any other say any other electronics and communication engineering application. So choosing the particular algorithm is a big task. Okay, so this is that means there are also some limitations. Although machine learning and artificial intelligence is a great field or some new field, whatever you may call, people are feeling crazy about it, but there are some limitations while applying these machine learning techniques to electronics and communication engineering or any branch of engineering. I have listed some points. Now what we have done is machine learning. We have studied what are the various types of machine learning, what is the workflow, what are some of the applications in electronics and communication engineering we have studied. Now how to do machine learning is the question. How to do in computer, how to do machine learning. It cannot be done using Excel sheet. I don't know whether it can be done in Excel sheet or not, but these are the two famous softwares which are going to be used for working with machine learning. One is the MATLAB software and other one is the Python software. So let us see, in case of MATLAB software, see machine learning toolbox is there, which contains statistics and machine learning toolbox. So in this, these are that means in order to have machine learning toolbox, you should remember that from R 2016, that means MATLAB version 6.57 will not work, may not work on this machine learning for machine learning purpose. You should have MATLAB version greater than R 2016. Every version is available freely in some Rahim software or some other websites. You can download. The R 2021A is also now available, freely available in the internet. So here he has given some of the toolboxes that was some of the new issues which has been present: regression, big data algorithms, code generation, statistics, and feature selection, feature extraction. These are the operations that can be done from R 2016 A or B onwards, R 2017, and R 2021 may contain. That means in R 2021, when I have attended one seminar, in machine learning, nothing we have to do. We have to give input. A machine learning algorithm block is there, and output is going to produce. No need to write a big code also. 1 or 2 lines code is more than sufficient. Next, this is about the things that can be done by statistics and machine learning toolbox. It can it can provide you answers with regression techniques, linear regression, generalized linear, non-linear, ANOVA, and these and big data algorithms for dimensionality reduction, univariate and multivariate probability distributions, random and quasi number generators, and hypothesis tests and distributions. So classification and unsupervised machine learning algorithms, including k-means, Gaussian mixture model, HMM, CTC. So all these are present in machine learning toolbox of MATLAB. At the same time, there is a neural network toolbox also. In this neural network toolbox, this is necessary whenever you are working with other branch of that means another subset of artificial intelligence, which is deep learning, which should contain more number of layers, which contains more number of deep learning is for big data. So deep learning with convolutional neural networks, and here is a descriptive list of key features of this neural network toolbox. Supervised learning algorithms, multi-layer perceptron, radial basis, learning vector and quantization, non-linear auto-regressive, regressive recurrent neural networks, and data fitting, pattern recognition, clustering. All these operations can be done using the neural network toolbox. Now let us go to the Python, which is the that means the disadvantage of the MATLAB is it is paid software, proprietary software, may not be available to everyone unless it is downloaded from unless it is downloaded or procured by the college. But this Python is the which is a high-level programming language. It is available freely in the internet. It was invented in the Netherlands by a person named as Rosum, who is shown in the picture, and he likes one comedy show, one show, TV show, which is Monty Python's Flying Circus. So based on this Monty Python, this programming language has been named Python, and he is the person, a person from Google company, who has started this Python software, who has invented this. So why we have to use Python, and who are the persons using this Python nowadays? Python is objective oriented. That means this supports concepts such as polymorphism, operational overloading, and multiple inheritance. All of you knowing, while studying about C language, you will study all these reasons. It is portable. That means it can work on Windows X, Windows 7, Windows 10, Unix operating systems. It is powerful. It contains so many number of libraries. In MATLAB, those libraries are going to be called as the toolboxes. Okay, and it is free. It is freely downloadable. That's why many people are using this generation. People are learning Python, and they are using it for project work in B.Tech as well as M.Tech. And these are the top companies. Google makes extensive use of Python in its website system and employs Python's creator. Intel Corporation, Cisco, Hewlett Packard, Seagate, Qualcomm, and IBM use Python for hardware testing. And YouTube video sharing service is largely written in Python, and many more companies are using this Python nowadays. So now, what are the libraries that are used for the useful for the electronics and communication engineering person? So there are some image processing libraries. They are nothing but NumPy and Scikit image, OpenCV, Mahotas, Simple TK, SciPy, Pillow or PAL. That means whenever you have installed the Python, if you have installed another one named as Anaconda, I think these libraries will comes into picture. So NumPy, it is used for to perform some tasks such as image cropping, masking, or manipulation of pixel values. Scikit image, it is used for segmentation, geometric transformations, color space manipulation, analysis, filtering, morphology, feature detection, and more. And OpenCV, it is used in computer vision tasks such as object detection, face recognition, image segmentation. And Mahotas, this includes thinning, morphological processing, template matching, etc. And simple TK library is used for image segmentation, image registration. SciPy is used to read images, image segmentation, convolution, face detection, feature extraction. Pillar pillow is reading image, rescaling the image, saving in image, different image formats, and and matplotlib is used for plotting all the images. These are the uh, libraries for image processing. The same libraries can also be used for machine learning. But let us see functions. In case of NumPy, it can perform useful for linear algebra, Fourier transform, and random number capabilities. SciPy, it contains different modules for optimization, linear algebra, integration, and statistics. Scikit-learn, this can be used for classification purpose, regression purpose, clustering purpose, dimensionality reduction, and model selection, pre-processing. And Theano is a powerful Python library used to define, evaluate, and optimize mathematical expressions involving multidimensional arrays in an effective manner. And TensorFlow is used in the field of deep learning research and applications, handling deep learning networks, natural language processing, partial differential equation, abstraction capabilities, image, text, speech recognition, and effortless collaboration of I don't know this speech recognition up to this TensorFlow finds applications. Similarly, Keras. So this is used to build a neural network. PyTorch is a library which is used in computer vision, natural language processing, and many more machine learning programs. Pandas is a popular Python library for data analysis. It is not directly related to machine learning, but it provides many built-in function, inbuilt methods for graphing, combining, and filtering of data. Matplotlib is a very popular Python library for data visualization. Like Pandas, it is not directly related to machine learning. These are the libraries which we should know in order to use. That means these libraries contain some function, some commands in it, and we will make use of those commands for our machine learning purpose. So this is my presentation. I have tried to give an idea of machine learning and its applications in electronics and communication. Some of the applications in electronics and communication engineering. Since this is a small 1 hour class, I have given a overview only in applications. If time is permitted, I can explain some algorithms how to attempt. So these are some references I have taken, and now I will end this session. If people has asked some doubts, I am ready to answer. Hello.
Thank you, sir.
Babu,
Thank you so much. Really,
information
though it is
kavalante
a short session, sir.
Amma Madam Krishna garu cheppandi.
Sir, please speak out, sir. I think you are saying something.
If anybody is having any doubts, or if you want new textbooks,
that's what, sir. Thank you so much. That even though it is
1 minute. Babu, any student is interested to have
definitely, sir. Definitely, sure, sir. Please talk, sir.
Good textbooks. You give an email at tkbattula@gmail.com. Mention your name and college. I will provide if you want anything help on this textbooks or anything. So now if anybody is having any doubts, they can ask.
So please, anybody for students or anybody, you can please ask the doubts.
ఎవరు వినలేదేమో, అసలు అర్థమైందో లేదు.
It's not like that, sir. Actually, they are they are in a hurry for their presentation. I think.
Okay, వాళ్ళ presentation ఉన్నాయి కదండి. Okay, whatever it may be.
But sir, but but it is really useful, sir. Though it is a short session, I also think that we have to keep it elaborated someday. And also, I request the students that here the email of B.T. Krishna sir is available over here. So, request all the students, if you have any doubts, please uh, do ask him. And B.T. Krishna sir, it's a lot of thanks from the bottom of our hearts. Really, really very useful, sir. This is real. I'm saying this from the bottom of my heart. So thank you so much, sir. That what you have said. Actually, we were new for this. I am new for this, but now I have got a certain idea about the session. Really, thank you very much, sir. It's really very valuable, though it. And now this session ends by this. And your session, students, it will start at 2 o'clock. So all the students who are having the sessions and the participants who are having the sessions, I request you to join your respective sessions by 2 sharp. So this is for the end of the session. I thank each and everybody once again, and also thank lots of thanks to Dr. B.T. Krishna sir.
Okay, thank you, madam. Thank you, Andy. లీవ్ అయిపోనండి.
Sir, thank you, B.T. Krishna. Thank you, sir.
Okay, thank you, sir.
Right, sir. You can leave, sir. Thank you.
Thank you, Amma.